This one's another rate problem, and this one's going to be the actual distance equals rate times time. So a more classic one in that we're dealing with a speed as our rate. So here we have Kyle, and he's taking a plane from Las Vegas to Los Angeles, which is a distance of 270 miles. And then from there, he's going to take a train, which goes from Los Angeles to Santa Barbara, and that's a distance of 100 miles. So basically, he's going from Vegas down to Los Angeles and then up the coast to Santa Barbara. And he's got 270 miles here and 100 miles here. We know that the train travels at 50 miles per hour, so that means that our rate here is 50 miles per hour. We also know that the plane travels at 300 miles per hour, so that's our rate in this leg of the trip. We're looking for Kyle's total travel time in hours. So we basically have two different equations here. We've got one for with the train, one for with the plane, and if we add up the two times from both, then we can figure out what we're doing. Because this equation has three variables in it, as long as I have two, I can solve for the other one. So here we're going to be solving for time, so I can go ahead and rearrange that equation so that the distance over the rate is equal to the time, and that just makes it easier when I'm doing the other two because I can directly plug in. So if I'm looking for the time that he spends on the train, I can use the distance that he travels on the train, so that's going to be 100 miles, and the rate that he's traveling at when he's on that train is 50 miles per hour. And here we basically have like a number divided by a fraction because of the way that this is written, and we'll do it just like that. So 100 miles divided by 50 miles per 1 hour, which means that I'm going to do 100 miles. I can put it over 1 if I want to, which we sometimes do when we're doing fraction multiplication times the inverse of this fraction. So 50 miles over 1 hour. And I can see that my miles are going to cancel out. And 100 divided by 50 is going to give me 2 hours. So we don't necessarily need to write this whole thing out every single time, but it's just good to make sure that our units cancel and to see what's actually going on. So if we want to do the plane, we can do that one a little bit quicker by just doing the time on the plane is going to be the distance, so 270 miles over the total rate that we're traveling at, so 300 miles per hour. And I know that just like up here, I'm going to get units of hours, which is good. That's what I want. But here, my number is actually going to be 0.9 hours. So because he's going so much faster in the plane, it's going to take him a lot less time to go this long distance than it is going to be to go the shorter distance between Los Angeles and Santa Barbara. But his total time is just going to be the addition of these two. So my answer here, once I'm done solving, is going to be that time total equals 2 plus 0.9 or 2.9 hours. This one would have been a little bit more work actually to solve as a proportion, but we could solve each where we're just doing, he goes 260 miles in X hours when he's going at 300 miles per 1 hour. And then when he's on the train, he's going at 50 miles per hour. And we want to know how many hours it's going to take him to go 100 miles. And then once we figure out these two, we could add them up and get the total time. So just like the last one, we can do it either way. It's up to you to decide. And play with a few rate problems and decide which one you like better and which one you're quicker at, and use that as your SAT strategy for these rate problems. Thank you again for tuning in to Educator.com, and I will see you in future SAT math prep videos.